Hello, what I want to talk about right now is the hydrolysis of nitriles. I previewed this in a previous video, but didn't talk about the mechanism. And this is a mechanism that is in the set of reactions that are carboxylic acid derivatives. And so it's important for us first to recognize that a nitrile is a carboxylic acid derivative. And when we think about carboxylic acid derivatives, we're thinking about any organic functional group that has a bond from one carbon to three electronegative elements, or three bonds to one or two to another, right? But the net result is adding up bonds to electronegative elements from carbon, and you can see we have three bonds to nitrogen here, one, two, three bonds to oxygen here. That's the hallmark of a carboxylic acid derivative, three bonds to electronegative elements. And the interesting thing is that any of those compounds with acid and water can be converted into a carboxylic acid. Right, so in this category are esters and amides. Those are the ones we're going to see the most, also acid chlorides. But the nitrile is sort of like a masked carboxylic acid, and you can unmask it by adding acid and water. And so I want to go through that mechanism so we can see exactly how we get from the nitrile to the carboxylic acid. So as with all of our reactions with acid, the first thing we're going to do is protonate the base. Right, and hopefully it's clear that we only have one base in here. We have the nitrogen, and so that's going to grab a proton. Now we can add the nucleophile. Right, so water can add. And again, it's important to note the order of doing these steps. We're going to protonate first, then add the nucleophile. If we added the nucleophile first, we generate a negatively charged nitrogen, which you cannot generate in acid. Right? Remember, in acid, we're going to have neutral and positive intermediates. We're not going to have negative intermediates because they're always going to be protonated by H+. Right, so this gets us to an intermediate that looks like that. We can do a proton transfer. Right, and we'll also note that we can draw a resonance structure of this. Right, and that might look a little more familiar to us because that's simply a protonated amide, right? So but as we just said previously, when you have amides and you have acid and water, you can continue to react, and then you're going to finish this reaction to get to the carboxylic acid. But I think it's important, if you're trying to remember, well, how do we remember what's going on in this? Remember, the first thing you do with a nitrile is you turn it into a protonated amide. Then from the amide, you can go to the carboxylic acid, right? And so we have the carbonyl protonated, so it's reactive. So we can add water, and that's going to give us a tetrahedral intermediate. And as we do in all these reactions, we're going to do a proton transfer so that we can protonate the nitrogen. And now we've made that nitrogen to a good leaving group because it's positively charged and can leave as neutral leaving group. And so we reform the carbonyl, have the nitrogen leave. So ammonia is our leaving group. We end up with a protonated carboxylic acid, and then we can use that amine base that we just generated to remove the proton giving us ammonium plus our carboxylic acid product. All right. So again, I think this is a really nice example of a hydrolysis mechanism where we're going to use acid and water. We can see that we generate our carboxylic acid, and I think just to fill in the picture here, we get ammonium as the other product. And again, really nice example of how we have 3 bonds to electronegative elements going to carboxylic acid, which is always going to be our product when we have a carboxylic acid treat with acid and water.